Hello guys, so let's begin the session. So guys, in this session we will talk about how to implement regression using AWS SageMaker. So basically in SageMaker we also have some built-in algorithms to perform regression, right? But first we will see how to implement regression using scikit-learn on SageMaker, right? And afterwards we will also go through about how to implement regression with the help of linear learner, right? So basically linear learner is a built-in algorithm in AWS SageMaker. Okay, so first let's see some basics of regression. So if we talk about simple linear regression, where we have to predict the value of one variable y based on another variable x. Here you can see this equation yi equal to b naught plus b1 xi. So here yi is the dependent variable and b naught is a constant, or we can say intercept, and xi is the independent variable and b1 is the slope, or we can say coefficient. So if we have only one feature or if we have only one variable, we can use this equation. So in the case of linear regression, which is a supervised machine learning, right, where we will have input data and output data. So with the help of this equation, we can find the yi, or we can say the value of prediction, right, corresponding to the input data. If we have more than one input variables, then we can just expand this equation, like y equal to b naught plus b1 x1 plus b2 x2, right? So this equation we can use if we have two variables. But here in this case, we are going to talk about when we have only one variable. So simple linear regression is a regression model that estimates the relationship between one independent variable and one dependent variable. So we have this independent variable and this dependent variable. And these are the data points and this is the regression line. So with the help of simple linear regression, we can find a straight line, right? Or we can say a regression line, right? With the help of coefficient and intercept. So whatever data we have, first we can find the value of m and b, right? And on the basis of such values, we can find a line here. If we talk about loss function that we can use in the case of regression, that is mean squared error, right? A loss function in machine learning is a measure of how accurately your model, your ML model, is able to predict the expected outcome, right? So with the help of loss function, we can just measure the ability of a model, right, to perform well on the test data, right? So we can just measure the performance of any machine learning model, right, on the test data. So the mean squared error is the simplest and most common used loss function. To calculate the mean squared error, we can take the difference between our model predictions and the ground truth, or we can say actual output, square it and average it out across the whole data set. And this is the formula here of mean squared error. 1 by n is the number of samples, summation I equal to 1 till n, then yi is the actual output of ith sample, then y hat I is the predicted output of the ith sample. Then we can take the square. So this is the formula of mean squared error. So with the help of this formula, we can measure the performance of any machine learning regression model on the given data set. Next, we will use here scikit-learn first, right? And then after we will see a built-in algorithm of SageMaker, that is linear learner first. But here first we will talk about scikit-learn. Right? So it is an open source Python library to implement machine learning. It offers several algorithms for classification, regression, and also for clustering. This library, which is largely written in Python, is built upon NumPy, SciPy, and NatPy. So NumPy we can use to deal with n-dimension array. SciPy we can use for scientific computing, and Matplotlib we can use for data visualization. It is also used for data pre-processing like feature scaling, label encoding, and splitting the data into train and test. Right. So before training a model, sometimes we have to perform feature scaling, right, or label encoding, right, and also before training a model, we have to split our data into train and test. So we will implement a linear regression with the help of a project here. Right. So the project is, suppose so you own an ice cream business and you would like to create a model that could predict the daily revenue in dollars based on the outside air temperature. So we have two variables here, input and output. So we have input variable here, right, which is also a feature here. And here we also have a target column, which is output y, right? So we have input, which is a air temperature, and output y we have as a daily revenue, right, in the form of dollars. So we will have data something like this one. Okay, so here you can see if the temperature is 24, then the revenue is this one. Temperature is 26, revenue is this one, right, and so on. So here we want to build a model that can make prediction on the basis of given temperature, right? So what will be the revenue? Suppose if we have a temperature 10, right? So such thing we can implement here. Okay, so let's implement a linear regression. So I'm going to log in into my AWS console account. So I'm going to do login from my user that I've created. So here I will not use my root user. Here I will use my IAM user. So first we need here 12-digit ID. Okay, let's just enter here username. Then let's see what will happen. We just enter here AWS ML engineer. Click on next. Here you can see. So here we are getting 12-digit account ID. Here we can enter the same username. Then we have to enter the password here. And here we will also see AWS service, that is S3. Right here we will also talk about S3. Simple storage service, and it is a storage service that allows to store and protect any amount of data. So if you want to store your data, you can also use here S3. You also have other options, right? And this is one of them. Okay, so let me SageMaker, we can just search here. Okay, and then we can click on notebook, then notebook instances. Now, currently there is no instance. Let's create a notebook instance here. So first we can pass a name, my first demo. Then here we can use a notebook instance for training, that is MLT3 medium, right? And this instance comes under free tier. And then for the inference here, we can just use the default value, and then we can use this platform. Okay, and here we can use also create a new role. Here we want to access any S3 bucket and create role. Okay, and then rest of the things here we want to use as default. Now click on create notebook instance. Okay, meanwhile we can see what is S3. So here we will use AWS service S3. So this is a simple storage service that we can use to store the data, right? So S3 allows customer to store data in the form of buckets, or we can say directories. A bucket is a container for the objects stored in Amazon S3. Objects are contained in the buckets. Means if we want to store the data, first we have to create a bucket, and inside the bucket we can store the data in the form of objects. Each of the buckets will have global unique name. right? And you can store an infinite amount of data in a bucket in which each object can contain up to 5 TB of the data, right? And that you can check here S3WS data. Just click on this link. You can see here for the S3, you can use 5 GB, right? So if you want to get some more detailed information about the S3 in the case of FreeTire, you can just search. Okay, let me check whether it is created or not. Okay, it will take few time. Okay, meanwhile, we can see how to create a S3 bucket. So we have services like here EC2. So EC2 we can use to create a virtual server, and then we can use a service IAM, right? And this IAM service we can use. Okay, we can say this service control who is authorized. Sorry, we can say who is authenticated and authorized to use AWS resources and services. Right. So here you can see the service. Okay. So here you can see the service IAM. Right. So this service basically we use to create the user, right, to access the AWS resources. Okay. Now here you can see the status in service. Now we can just click on this open Jupyter. Okay. So it will take some time. So meanwhile, we can. Okay. So here you can see services SageMaker, EC2, S3, IAM. So these are the main services here. We also have some more AWS services, but these are the main EC2, S3, and IAM. Okay, here we can create a new notebook. So if you want to do machine learning using Spark, using Python, you can use this notebook, PySpark. We also have here TensorFlow, PyTorch, with the help of NextNet. But here I'm going to use this one, Conda Python 3. Okay, so here we will use scikit-learn, and you can see what is scikit-learn here. So scikit-learn is a open source Python library for machine learning, and this is the official website of scikit-learn. Scikit-learn. So this is a machine learning in Python. So using scikit-learn, you can implement classification, regression, clustering, dimension reduction, model selection, data preprocessing. Right? So all these things you can implement with the help of scikit-learn. So first we will see a demo of for the scikit-learn on AWS SageMaker. I don't know why it is taking so much time. Okay, just give me a few minutes here. So if you want to create a EC2 instance, you can just search for this and just enter. And okay, now here you can see. Okay, if you want to give a name, so you can just write my ML code one, rename this. Okay, here you can see, here you can run any Python code, print x plus 3, we are getting 6, right? So we can run here Python code. Okay, and let me check whether we have installed here scikit-learn or not. So we can just import it here with sklearn. Here we have to import this scikit-learn library with the help of sklearn. So you can see if we are not getting any error, it means scikit-learn installed here already. Import SQL. Here you can see we are not getting any error. Port numpy as np, port pandas as pd, And we can also here import matplotlib dot pyplot as so import matplotlib.pyplot as PLT. So here you can see scikit-learn, NumPy, pandas, matplotlib, all these library are installed already. Okay. So here we want to implement a machine learning on this, on the data. So here we want to first upload the data and the Jupyter notebook. So we have data into this file, iScreenReader.csv. Click on this upload. And here we will also upload our Jupyter notebook file. Click on upload. Okay, now we want to run this one, project code. Here instead of PySpark, we will use Conda Python 3 kernel. Okay, so first we can, okay, let me check whether we have installed Cbon or not. So import Cbon. If you don't have this library, so this library you can install with the help of this command. Okay, you can see we are not getting any error here. Okay, so restart and clear output. So first we can import some necessary libraries here: pandas, numpy, cbound, matplotlib. Okay, next we can read CSV file. So CSV file is iScreenData.csv, right? So we can in pandas we have a function read underscore CSV. So pandas is a Python library that we can use for data analysis, right? So we can use this function, we can pass the file name, and we will get the data in the form of data frame. Okay, and data frame is a two-dimensional data structure, right, which consists data in the form of rows and columns. Now, if you want to display first five record, we can call method here head. You can see we have two columns here, temperature and revenue. So temperature is an input column and revenue is a target column. So this is feature and this is our target column or target variable. If you want to see the last five record, so here you can use the method pay. Okay, next if you want to explore the data, so here we can use method describe. Right, and this method we can use to get some static information about the data. You can see here we are getting number of count means number of samples. Okay, if you want, okay, let's check the shape for this data. So dot shape, here we can use attribute shape. So here we have 500 rows and 2 columns. So here you can see in the count we are getting 500. It means there is no missing data. Mean is 22 for the temperature and for the revenue is 521. Standard deviation is 8.0 and for the revenue 175. Minimum value is 0. Here minimum value is 10. And this is our Q1, Q2, Q3, and this is the maximum value. Okay, now let's perform some data visualization. So here we want to display our column temperature, right, in the form of histogram. So here we have a function hist. We can mention the number of bins, figure size, color. You can see this is a histogram of our column temperature. So you can see here we are all the values are very close to each other. And if you want to do plot the data pairwise, so you can use this function pair plot. Right? So sns.pairplot, and here we can pass the data frame. Okay, so you can see this is a data visualization for temperature. This is for revenue, and here you can see this is for revenue and temperature, and this is for revenue and temperature. Prepare the data for model training. So x equal to, okay, now here we are trying to store our feature into a variable x, and our target variable into a y. So this is our x, where we have column temperature, and this is y, where we have target column revenue. So similarly, if you have more than one feature, so all the features we can store into a separate variable, right? And the target column we can store into a another variable. So x dot shape, you can see 500 comma 1. Then y dot shape, here you can, the shape here is 500 comma 1 also. Next, we will convert our data here into the D type float 32, right? So np.array x. So here we have data in the form of data frame, but here we are trying to convert our data in the form of array, and the data type is float 32. Now we have this x in the form of array, and y also we have in the form of array. Next, we will split the data. So from sklearn.model selection import train task split. So from sklearn.model selection import train task, and we can call this function. We can pass our x, y, and test size. So here test size I have taken 0.2, means 20% data we want to keep for testing, and that's 80% data we want to use for training. And here we will get four variables. Here we have four variables x train. So here we will get train input in x test. Here we will get test input, y train, and y test. Okay, next here we can import our model linear regression. So from sklearn.linear model import linear regression. From sklearn.matrices import mean squared error. So mean squared error basically is a loss function. So if you want to check our model performance on given data set, either you can use your mean squared error, or you can also find the accuracy of the model on the given data set. So here we can also use an accuracy score. Next, we have to initialize the model, and then we can call fit method here. So if we call fit method, it means we are trying to train our model with the help of given data, and given data is x train and y train. So in this line, we are trying to train our model with x train and y train data. Okay, next, if you want to see the coefficient and intercept, so here we have an attribute that is model dot coef. You can see this is the coefficient model dot intercept. You can see 46. So this is coefficient m, and this is intercept b. Next, we can check the model performance on the test data. So we can use model score. Another way we can find the prediction, and then we can use here function accuracy score, right? Okay, and here instead of that, we can also use the method score. So if we use method score, here we have to pass the input and output data, and we will get the accuracy. So if we pass x test, y test, and here we are getting accuracy 98%. Okay, and another way is we can call method predict. We can pass our input data, which is here x test, and we will get the predictions here. And the same score we can find with the help of accuracy score function. You can see accuracy score, and here we can pass, and here, okay, we can also check the documentation. So here we can pass first y true, means actual output that we have in y test, comma, y test, comma, and then we can use y predict here, predicted output. Sorry, I think there is some error. An accuracy score. Content is not supported. Sorry, we cannot use here accuracy score because okay, because this is a regression problem, right? Accuracy score basically we use for classification. So this function we use only for classification, and this is a regression problem, so we cannot use here accuracy score. Yes, so we have here one more function, that is R2 score. So in the case of regression, we can also use here R2 score, this one. So instead of this accuracy score, we can use here R2 score, and here we can pass. We can also check the documentation. So first we can pass the actual output that we have in y test, comma, and then we can pass here predicted values that we have in y pred. You can see we are getting the same score here, 0.98. Also here we are getting the 0.9. Right, so this is how we can find the accuracy score. Then if you want to display the performance, so we can use a scatter plot. We can here display the data, and we can set the y label, x label, and title, and we can also set the grid in the background. You can see here. So here we are trying to plot our x train and y train data, right? And here we are trying to find the line with the help of plt.plot, right? So this line here we are trying here. Okay, so this line we can display with the help of this function plot. So we can pass input data and output data. So output data here we are passing with the help of method predict, right? Color is right here, right? So this is a regression line here. So here you can see this line is very close to the given data points, right? So it means our model performing well on these given data points. The same thing we can do for our test data, right? So here scatter means we can display our data, which is here x test, y test. We can display the line here. We can set the label, x label, y label, set the title, and then grade. You can see. So this line, this regression line is very close to the given data points here. So it means our model also performing well on this test data point, right? These are the test data points. Right, so this is how we can implement scikit-learn on AWS. Okay, next here we will see how to create a bucket in S3, right? And how to upload the data into S3, and then after how to fetch the data from S3. Okay. So if you want to create a S3 here, you can search here S3. So S3 is a storage service that allows us to store and protect any amount of data. So let's create a bucket here. So we have to store our data in the form of objects. And here we have to pass a unique name. So let's pass here my ML data. Okay, and this is the reason. And okay, this. Okay, and here we have this option, block all the public access, means no one can access your bucket. Okay, and that sort of thing we can just keep the default. Next, let's create a bucket here. Here you can see this bucket with this name already exists. So my ML data, let's pass here my ML first demo. Let's then click on this create bucket. Okay, next this go inside this bucket, and here we want to upload some data. Click on this upload. So we want to add file here. So we want to store the CSV file into this bucket, and then and you can see this is a link here, S3, and then bucket name, right? And then here we will get the file name. Then click on upload. You can see this file has uploaded into this bucket. Close this, and here you can see this is our first bucket, my ML first demo. And if you go inside this bucket, and this is our data. Now this data we want to access here into this Jupyter notebook. Here into this Jupyter notebook. Okay. So what will be the code here? Similarly, if you want to save your trained model, right? So that model you can also save here into this bucket. Okay. Now here we can write some code to access that CSV file. Okay. So here we can use a library import Boto3. So it allows to directly create, update, and delete AWS resources from Python script, right? Or we can say this is a Python SDK for AWS. And this library make it easy to integrate our Python code with AWS services like S3, EC2, and many others. You can also search about this library, Boto3. You can see we can use AWS SDK for Python to create, configure, manage AWS resources, right, using Python script. So we can import Boto3, and then we can mention the client equal to S3, not S3, sorry, Boto3 dot client S3 path equal to S3. This next we have to mention a bucket name, or if we want to get the path, so we can just here you can see the option copy the URL or copy S3 URI. Just click, you can see. I think instead of copy URL, we have to copy this, copy S3 URI. Yes, this one. So S3, then bucket name, then file name, right? So path equal to this. So first we have to mention this S3 colon and then bucket name. So whatever bucket name we have taken, that we can pass here, and then file name, or we can say key name, right? Next, pandas we have already imported here. Okay. Next, we can read the file df equal to pd dot read csv, and then path. Now you can see we are getting no error. Now df dot head. You can see we are getting the data here, right? So this is how we can read the data from our bucket. So this code we can run here, restart Angular output. So import Boto3, and instead of this, so we can just copy this code, and then we can copy this line path. Okay. Next we can just copy this line also and paste it here. So we can just comment this one, and we can use the same variable name here. You can see, right? And rest of the code will be here same. So this is how we can read data from S3. Okay, after this, if you want to save our model, where is one model? This one model. right? We want to save this model because this is a trained model, right? And this model we want to save into S3 bucket. So how we can save our model into S3 bucket? I think for that we have to use a library temp file. Okay, so here we can check about temp file Python library. Generate temporary files and directories. Okay, so we have to use this library. So how we can save our model? Okay, so let me check import temp file, and then we can mention the S3 equal to go to 3 dot resource, and here we can pass the S3, and then we can mention the location. Okay, let's take a location S3, then bucket name. I think bucket name is my ML first time. Then the folder name. Okay, let's take a folder name uh, model. Let's take a train model. Okay, and a file name. You can take a model file name equal to. We want to save our model as a model.pkl pickle library. So pkl basically is the extension of pickle file. So in Python, if you want to save a Python object, if you want to save a Python object, we can use here a pickle module. So here we will try to save our model with the help of pickle. Okay, and output file name equal to location plus model file name. Not location, it will be loc only. Okay, and here also we have to put the forward slash this. Then we can use with temp file dot temporary file as fp, then joblib dot dump. The joblib is also a Python library to save a Python object. So we want to dump our model fp. I think here we have to also import this, import joblib. Okay, and then fp dot seek index 0, and we want to save this into a bucket. So s3 dot bucket, then bucket name my ml first demo dot put object. Here we can pass e equal to output file name, and body equal to fp dot read. Oh, here we are getting some error. Let me check. Parameter here key, it should be in uppercase. I think similarly here the p of body should be in uppercase. Okay, now we can check our S3. So we have this bucket, and refresh this. My first demo. Where is our model? I think here we have to create a folder first. Folder is trained model. Let me check what we have this. First, you can see here, you can see our model has saved here, right? So this is a code here to save our model. So after this, once you are done, so we have to close all the files. We have to terminate all the instances. So shut down, close. Also, we have to delete this bucket. Okay, before that, we have to just make it empty. Delete, delete objects. Okay, and now here we are going to delete this bucket also. Enter the name, my ML first demo. To delete everything that we have just created. So after this here we will also delete this notebook instance. So first we have to just stop this. Otherwise we have to pay some charges. So if you don't want to pay any charge, so once you are done, so please stop all the instances or delete all the buckets. It will take just a few minutes. Meanwhile, you can check any other file or any other thing that is open. So you can check for S3. You can see there is no bucket. Okay, just refresh this. So after stopping this, next we can just delete it. Okay, so okay guys, so I think it is enough for today's session. In the next session, we will talk about inbuilt module of AWS SageMaker, that is linear learner. Okay, so we will implement regression with the help of linear learner. Okay guys, so let's wind up this session and let's meet in the next class. Thank you.